Hello, grade 7 students. In today's lesson, we're going to concentrate on the single replacement reaction. Before starting, I would like to welcome Sami Abu Bakr. Thank you, Sami, for this lovely participation. Let's take a look at this chemical reaction. In front of us, a copper wire immersed in a solution of silver nitrate. Sami, what are the two metals shown in this chemical reaction?
The two metals are copper and silver.
Let's describe each of these two metals. What's the physical state of copper at the beginning of this reaction?
Copper is solid.
What about the physical state of silver?
Silver is at an ionic state dissolved in the solution.
Great. Now, compare the color of the solution at the beginning and at the end.
At the beginning, the color of the solution was silvery white. This color has changed into blue with time.
What does this change in color mean?
It means that a new substance is created due to a chemical reaction.
What is this new substance which has a blue color?
The blue color reveals that copper, which was originally a solid metal, turned into an ion dissolved in the solution.
Great. Now, let's describe that silver at the beginning and at the end of the chemical reaction.
The silver, which was ionic, dissolved in the solution, turned into a solid metal.
Good. Now, let's compare the reactivity of copper to the reactivity of silver.
In order for the copper to replace the silver in the solution, copper must be more reactive than silver.
Excellent. To sum up, in order for a chemical reaction to take place between the solid copper and the solution of silver nitrate, copper must be more reactive than silver, which is clearly shown on the reactivity scale below. Accordingly, copper, which was a solid, will turn into ions and replaces the silver, so it gives the solution a blue color. Similarly, the silver, which was dissolved in the solution, will turn into a solid. Now, let's treat the reaction between zinc and copper sulfate. The chemical reaction takes place between which metals?
The chemical reaction takes place between zinc and copper.
Let's describe the physical state of zinc.
The physical state of zinc is a solid.
What does this blue color reveal about copper?
The blue color reveals that originally copper was dissolved in the solution.
Describe the color of the solution at the end of the reaction.
The blue color disappeared.
So, what does this mean?
It means that there are no copper ions in the solution anymore.
What happened to the copper ions which were dissolved in the solution?
Here, copper turned from its ionic state into a solid state due to a chemical reaction.
Great. Now, compare the reactivity of zinc to the reactivity of copper.
Zinc is more reactive than copper.
Good. So, let's describe the chemical reaction which took place between zinc and copper nitrate.
Accordingly, zinc was originally a solid metal, will replace copper and turns into zinc ions dissolved in the solution. Similarly, copper, which was dissolved in the solution, will turn into a solid copper.
Now, let's predict the product of the following reactions. Magnesium plus copper sulfate. First, what are the metals included in this chemical reaction?
The two metals are magnesium and copper.
Let's compare the reactivity of these two metals.
Magnesium is more reactive than copper.
Great. What are the products of this chemical reaction?
Magnesium breaks copper in order to give copper and magnesium sulfate.
So, magnesium, which was originally a solid, will turn into its ionic state and dissolve in the solution to form magnesium sulfate. Similarly, copper, which was dissolved in the solution, will turn into a solid metal. Now, let's predict the product of the reaction between magnesium and calcium sulfate. What are the two metals included in this chemical reaction?
Magnesium and calcium.
Let's compare the reactivity of these two metals.
Magnesium is less reactive than calcium.
Is there a chemical reaction between magnesium and calcium sulfate?
No, there is no reaction because magnesium is less reactive than calcium.
Thank you, Sami, for this lovely participation.